cross product. The cross product is an operator that takes two vectors like the dot product, but it also produces a vector, okay? Unlike the dot product where it just produces scalar or just a number, okay? So the cross product, it also has two definitions. The second one, the more algebraic one, is a little long and tedious, and it's in fact the one that we're going to use most often to actually carry out cross product calculations, but it's less interesting than the first one. So let's pay attention to the first one. So the first one says the cross product of u and v is equal to the magnitudes of u and v multiplied by one another times the sine of the angle. And then there's this new piece, n. Well, n is what makes the cross product expression a vector, okay? So this is the magnitude of the cross product, and this is the direction of the cross product. Now, n is always going to be sort of like a placeholder, and what n is signifying is a vector that is perpendicular to both u and v, okay? So if you think of u, if you think this is u and v, and if you think of this board as the plane that u and v comprise, then the cross product of u and v will be perpendicular to both of them, and thus the board, and so it'll be coming out or going into the board. To figure out whether it's coming out or going into the board, because remember, those are two different directions. One is going this way, the other is going that way, okay? To figure out if it's going in or coming out, we use what's called the right-hand rule. You place your right hand along the first vector. We're doing u cross v, so u is the first vector, so I'm going to place my right hand along u, and then I'm going to curl my fingers towards v, okay? I'm going to curl my fingers towards v, and whatever direction my thumb is pointing in, that is the direction of the cross product, okay? So you curl out, okay, it's coming out, so it's going to be coming out of the board, and that's the symbol for coming out. It's just a circle with a little dot in the middle. If it were going in, I would draw a circle with an X, sort of like the end of an arrow, okay? So, all right. So that's the definition, and one of the cool things about it again is the fact that the direction of the cross product is basically the direction of the vector perpendicular to both u and v. Well, is there anything in particular or special about the magnitude of the cross product? Well, yes. The magnitude of the cross product, if you follow along really quickly, let's say we have u and v, and we're interested in knowing the cross product. Well, it says it's the magnitude of u, so this vector, or that length, times v sine theta. Well, what is v sine theta? If this is theta, v sine theta is this guy, right? Because that's theta is a little right triangle, so v sine theta is just this length, okay? If we go ahead and complete this little parallelogram, we'll see that what we've actually done is multiplied the base of the parallelogram by its height. So we've calculated the area of the parallelogram inadvertently when calculating the cross product. Well, that's not really inadvertent. That's one of the properties of the cross product. When you have a cross product of two vectors, the magnitude of your cross product is also the area of the parallelogram that those two vectors comprise. Okay? So let's go ahead and do an example really quickly with these two vectors to see how this business actually gets carried out. Well, we're going to use determinants to do it, okay? And we're going to do it in the following way. We're going to write I, J, K, our three magnitudes, our three unit vectors, so the bases for our three-dimensional vector space. And then we got 3, 5, 2, and 6, 4, 1. Remember, the order here matters. So it matters whether I say 6, 4, 1, 3, 5, 2, or 3, 5, 2, 6, 4, 1. In fact, the answer that I'm going to get is going to be negated, whichever way I use. So if I did it the other way, I would get negative of whatever answer I end up getting. So let's go ahead and do this. And there are a couple ways you can calculate the determinant of this matrix, but the way I usually do it is just, okay, for I, I'm going to block these two rows, this row and this column. So I'm left with this little matrix, and the determinant of that is just 5 times 1 minus 2 times 4, so minus 3, plus j. Now I'm going to block off this row and this column, so I have 3 times 1 minus 2 times 6, so 3 minus 12, or minus 9. And then I'm going to negate j, because it goes plus, minus, plus. Okay? If you aren't really familiar with this, you probably should look up sort of finding the determinant of a 3 by 3 matrix, and this will make more sense. So then I'm going to do k hat. Then it will be 12 minus 30, or minus 18. So now we have our cross product. And that is it. As you can see, it's obviously a vector, and I'm guaranteed that for one thing, if I took the magnitude of this guy, I will get the area of the parallelogram that these two vectors comprise. And if I took its direction, then that is also going to be the direction of a vector that is perpendicular to both u and v. So there you have it. It's the cross product and a couple applications of it.